about a Schottky defect. Schottky defect is a type of primary point defect in a crystal. It occurs when an equal number of cation and anion are missing from the lattice site. This creates an empty space in the crystal structure, which are known as vacancies. This phenomenon is called a Schottky defect. Let me give you some example. Imagine NaCl. If one Na plus ion and one Cl minus ion are missing from the lattice site, a vacancy is formed. Even though ions are missing, the crystal remains electrically neutral because the number of positive and negative ion loss is same. That's all from me about the Schottky defect.
Hello everyone, my name is Muhammad Idil Kashaliman bin Budaliman, and I'm going to explain about a Frankel defect. To make it easy to understand, a Frankel defect is one of the reasons a crystal can be imperfect. This phenomenon usually occurs when an atoms and ions leave its normal lattice positions and move into an interstitial site. And for your information, interstitial sites is the empty space between other atoms. The characteristic of a Frankel defect. A Frankel defect is a stoichiometry, so the chemical compound of the formula remain unchanged. Different from a Schottky defect, the density of the crystal remains the same because no ion actually leave the solid. The electrical neutrality of the crystal stay natural, and the conditions Frankel defects to occur is the large difference in the size of the cation and anion.
Hi, I'm Izzat Fadli, and I will explain the planar defect. So the planar defect is the imperfections, the extent of a plane in a crystal lattice. That is a 2D defect. So there are 4 types of planar defect. That is grain boundaries, twin boundaries, stacking faults, and phase boundaries. In this presentation, we only explain about the stacking faults and the grain boundaries. As you can see from the example in the slide, that is the example of grain boundaries and stacking faults. So, stacking fault is a planar defect that caused by an interruption in the normal stacking sequence of atomic planes in a crystal. There are 2 types of stacking fault. That is intrinsic and extrinsic stacking fault. For intrinsic stacking fault, there are missing of one sequence from the stacking sequence, while the extrinsic stacking fault, there are an extra sequence in the stacking sequence. So what causes this stacking fault? Stacking fault may occur due to plastic deformation and can occur due to partial dislocation. From the example in the slide, you can see that the intrinsic stacking fault have a missing of C sequence from the stacking sequence, while for the extrinsic stacking fault, there are an extra of S sequence in the stacking sequence. So the effect of this stacking fault is that it will reduce the crystal symmetry. It can affect the mechanical properties, that is strength and ductility, and it will influence the dislocation movement, and it will affect the thermal and electrical properties.
Hi, I'm Mirna, and I will present about grain boundary. Grain boundary is boundary between crystal grain with different orientation. It affects material properties like strength and ductility. For example, in making iron play an important part in deciding how strong the iron is. By controlling the size of the grain, iron makers can produce stronger and longer lasting iron. This improves the quality of the iron product and can save the production cost. So understanding about grain boundary is important for new idea and better technology. That's all from me. Thank you.